the link to my, let me put the link to my GitHub so you guys can get the file. We're not using the bachelor file this event, we're gonna use the next event. For now, we're gonna teach like the basics of Python. So let me put it in the chat real quick. You guys should open that and then click on the Python. Sure. Yeah. So yeah, click on the Python workshop 1 file, and you'll have an option here that says open and collab. So we're using we're using Google Colab, which is like this whole thing. It's basically like a Python editor in Google, so we don't have to download any IDEs to like actually install things. It just makes it easier. So make sure to open it, click this button, and make sure to open it in a new tab, because that's the only way I seem to get it to work. If you have any questions, just feel free to ask, please. Hey, Daniel. All right, we'll get started soon. I mean, I think it's 12:37. So you know what? Let's just get started if everyone's ready. Yeah, our president is here looking at us now. Doesn't make me nervous at all. Okay. So let's get started on this workshop. Just remember to make sure to open it in Collab so you guys can work alongside me, or at least see it run. So yeah, let's start. Okay, so welcome to our beginner Python workshop. This is Python workshop number 1. This is a 2-parter workshop. For the first one, I'm trying to teach you guys the basics of Python. Like, it's not all the basics because obviously we only have an hour and a half, but it's enough to like give you a foundation of how to work with Python. So the next workshop will work with we'll start working with a data set and pandas, but I'll teach you more of that next time. So let's start off really simply with comments. Now, comments are like useful in Python because when people are working on your code, like sometimes you bring other developers to work on your code and you want to explain certain lines of code or to make codes more readable, right? So you do something called a comment. Now, there's 2 types of comments. You can make a single line comment, which begins with a pound key, right? So if you just put a pound key and you put anything after the pound key, it will be considered a comment if it's on that line. And writing a comment does not affect any of the output of your code, right? So like you have that, and you also have multi-line comments where you can put comments on multiple lines, because single line comments only work on one. So to make multi-line comments, you just have to put 3 quotation marks. It could be single or double in the beginning, and 3 in the end, wherever you want to end it, right? And comments are also useful when you want to prevent execution of certain lines of code when you're testing out a program, right? Like let's say I have like 10 lines of code and I know something is a problem, something's like giving me a bug in the program. I can comment out some of the code so I can figure out exactly what it is. All right, so now we'll start with the print function as well. So in order to produce output in Python, you must use the print function. So we'll start out with the old reliable here, print hello world, right? Now, if you print hello world, you can see down here when you run it, it actually prints out the word hello world. Now, hello world in this context is called a string, right? So this line of code is outputting a string, or str, which stands for string data type. Now, strings usually refer to letters or words, and they must always be encapsulated with quotations. It could be double quotes or single quotes. So it must always be encapsulated in quotations when you want to print out a string. Now, there's a function in Python that's very useful. You said collab isn't working. Can you explain to me why? Like, what's happening?
Yeah. When I click on collab, it just leads to like a gray, like blank page.
Oh,
It
yeah,
doesn't
yes.
like take me to another page where I can actually.
So make sure to open it in a new tab. So right click it and open it in a new tab. And hope like that's what cleared it up for me.
Okay, let me see.
Yeah. Is everyone else's collab working? Can someone type in the chat if it's working for them?
Okay, I got it.
Works. All right, cool. So yeah, so if you print a string, which is letters and words, it has to be encapsulated in quotations. Now there's a function in Python called type, right? And it stands for basically data type, which are like strings or integers or floats. And it basically checks what you print out, and it checks what kind of data type it is. So if I put print type hello world, it's gonna tell me that it's a string. You see here, str string. So we're printing the type for all of these, right? Like if we print the type for I love AIS, it gives me a string. If I print the type for Baruch students are smart or AIS is the best, it prints out string. Now, note that when you're encapsulating strings in quotation marks, I think a best practice is to use double quotes, because sometimes you want to print out words with apostrophes. And if you print it using single quotes, it's gonna mess up like the format. You see here, like if I put single quotes, it's gonna recognize Baruch student as a string, but it's not gonna recognize these after the apostrophe. So make sure to use double quotes. All right, now we're on to another type of data type, which is called integers. Now, integers refer to positive and negative numbers with no decimals. Like they're just whole numbers like 2, 3, 50, 105, things like that. They differ from strings when using the print function because they don't need to be encapsulated in quotations. So before, you know how we said every string has to be between 2 quotation marks? Integers do not. So if I want to print an integer, I just print the number. So print 55, it'll come out as 55. And you see when we print the type, it comes out as class integer. And this also works with negative numbers. You see here, negative 55, the type is integer. Are there any questions about strings or integers? Okay, so let's move on to floats. So float is another data type, and it's also refers to numbers, but they refer to positive and negative numbers that contain decimals. Like they have to have like decimals basically. So like integers, they don't need to be encapsulated in quotations. So you see here, I just print 69.9 and it prints that out, and the class is a float. The data type is a float. And the same thing with 24, right? We have the float data type. Now in Python, if you do any fractions, if you try to print out any fractions, they are considered float, regardless if they have a remainder or not, right? Regardless if they have a decimal or not. So if you see here, if we print negative 69 divided by 9, we get negative 7.66, right? And that's considered a float. Obviously, you see the decimals. But if we did 30 divided by 10, you might think it'll give us an integer because the answer is just 3. But because it's a fraction, it'll return 3.0 and it's considered a float. So yeah, and also remember that anything you print out that's encapsulated in quotations are considered strings. So even if you print out a number and you put it between 2 quotations, Python's gonna recognize it as a string, not an integer. So as you see here, when we print 69.9 in between the quotations, the class is considered a string. Does anyone have any questions about floats? All right, cool. So Booleans are the last data type that we'll go over. Now, Booleans are a little weirder. They're a data type in Python that represents either true or false. So it's usually used to represent values in expressions like mathematical expressions, like, oh, is 1 greater than 2, things like that. So Booleans also don't need to be encapsulated in quotation marks. You just write out whether it's true or false. It depends. The use differs through some things, but on the compiler, true or false will be bolded in blue. And also when you type in a Boolean true or false, the first letter has to be capitalized. So it has to be true and false with capital letters. As you see here, when I print out the type true and false, it comes out as Boolean, right? Now here are some Boolean expressions to further show how Booleans work. So like I said, they're like mathematical expressions. So here we want to see if 1 is equal to 1. So if 1 is equal to 1, we obviously know that that's true. So it'll print out right here, it'll print out true. Now, this double equal sign is not what we're used to in regular math. In regular math, we usually just use a 1 equal sign. But in Python, a single equal sign isn't used for expressions because it's a single equal sign in Python is considered an assignment operator. It's used when we want to assign a value to a variable, but we'll discuss variables later. For now, you just know that if you want to compare one value to another, you have to use a double equal sign. So we're printing out 1 equal to 1. Python's going to know that's true, so it prints out true. Now, a not equal sign is basically represented by an exclamation mark and an equal sign. So if you put an exclamation mark next to an equal sign, Python knows it means not equal. So if we print out 1 is not equal to 1, Python is going to be like, oh, wait, that's false because 1 is equal to 1. So it prints out right here, false. It's printing out in a line because I put them all in the same, box. But so here it's showing 2 is greater than 1. We know that's true, so it'll print out true. 2 is less than or equal to 3. We know that's true, so it'll print out true. And for Booleans with strings, it'll only come out to true if every single letter is equal to every single letter of that you're trying to compare, right? So we know AIS, it says here AIS equals AS, but we know that's false because they're not the same word. So that's false. Any questions about bools? All right, so mathematical operations. Now, the mathematical operations used in Python are very similar to the ones that we use in everyday math, right? So here, for example, if we want to print out the two numbers, like if you want to add two numbers in Python, it lets you do that. It's like a mini calculator sometimes, right? So if we do print 1 plus 1, it'll print out 2, obviously, because that's true. If we can do a subtraction, so we could print 2 minus 1, and it'll be 1. We could do division, so 3 divided by 2 is equal to 1.5. See, if you run it, it's 1.5. We could do multiplication, so print 4 times 2 will be 8. And there are two operations that might not be familiar to you guys, and they're called the modulus and exponent operators, right? So the modulus operator is basically the remainder operator. So if you put a percentage between two numbers, it's gonna divide the first number by the second number and only return the remainder. So for example, if I do 10 modulus 3, we know that 3 goes into 10 3 times and gives us 9, right? With a remainder of 1. Therefore, modulus will return only 1. It won't return the answer and the remainder. It will just return 1. Now for exponents, the exponent operator is different from how we use it in math. Like usually on a calculator, we would use like the arrow facing up key, right? Like this one. If we put like 5 to the second power on a calculator, it'll be like 5 up arrow 2, right? But in Python, we use 2 multiplication signs to represent exponents. So if we want to do 5 to the second power, we do 5 and then 2 multiplication signs and then 2. So it'll come out to 25. So yeah, that's basically simple mathematical operations in Python. Okay. Sorry, give me a second. Now, variables. This is important. This is a very important concept in Python because we'll probably use it in every program we ever use in Python. Now, they're an important concept in Python because they're basically containers for storing data values. And as you said before, data values are strings, integers, floats, Booleans, stuff like that, right? Now, the syntax for variables is that the left side is the variable that we want to represent, and the right side is the value we want to assign to the variable. Now, there are some rules. Yeah, the recording will be shared with you guys, don't worry. Now, there are some rules to variables when you make them, right? So number 1, try not to, just don't make your variables keywords, right? Like if, else, return, true. We haven't gone over if, else, or return that. We won't in this workshop, but you can always look up a list of Python keywords online for more examples and just make sure you never name your variables that, because Python will recognize it as a variable. It'll recognize it as that keyword. Number 2, your variable name must always start with a letter from A to Z, lowercase, A to Z, uppercase, or an underscore character. You cannot start a variable name with numbers. Like, it just won't work. Number 3 is make variable names that make sense with what's being assigned to them. Now, technically, you don't have to have variable names that make sense. You can call any of your variables X or Y or whatever you want to call them, but it's considered good practice to do it. So like, for example, if we're like making a program or a variable that like has a value that's equal to like a bond price, we want to name the variable bond price. So this is also like for better readability. So if someone like another developer wants to jump in on your code, they know exactly what each variable has, right? It makes sense like that. Like if they came in and they saw X, they're not going to know what X is. So another rule is that variables are case sensitive. So like if we name a variable apple, which with a capital A, it's not the same as apple with a lowercase a. So make sure you're careful with the lowercase and uppercase you put in your variable names. And lastly, the last rule is a variable name cannot contain spaces, right? So if you want to show a space in your variable names, make sure to put an underscore or something like that, but you cannot put a space because then Python will recognize it as 2 separate words. Now here are some examples of variables. So I made a variable named ex, for example, and I set it equal to a string named word, right? Because we can set a variable equal to any data type. So I put example equals word, and when I print the variable, so you have to print the variable, not the word itself. So when I print example, word comes out because that's the data type that example variable holds, right? And as you see, when I print the type, it'll print out string. Now, another example would be I named this variable example2, and I set it equal to 4.0, which is a flow, right? So when I print example2, it comes out as 4.0, and the type will be of type float. Now, variables are also useful because you can do things like this, right? Like, let's say I want to calculate the area of a square or something, right? A rectangle, I don't know. We can set like a variable width equals to 10, a variable length equals to 5. So we know that, oh, 10 is the width and length is 5. And I basically make another variable named area, and I set it equal to the width variable times the length variable. So now I got area, right? So when I print out area, it gives me 50, right? Because it's doing 10 times 5. It's basically Python's looking to what value is assigned to width and length. And it multiplies them and adds it and assigns it to a new variable named area. And as you can see, it's of class integer because it's not a float, obviously. It's just a whole number. So you can redefine variables in Python by assigning another data value to the variable you want to define. So it's just easier to explain to show an example, right? So let's say we have a variable here called var1, which stands for variable 1, and we set it equal to a float 3.0, right? So when you print it out, it's 3.0. But let's say, hey, I made a mistake and I want to change the value of var1. So I just write var1 again, and I just set it to another number. So I set it to 3.5, and now var1 is equal to 3.5. 3.0 does not exist anymore for it. It's just 3.5. Now, we can also reassign variables to another data type using casting. Now, casting is basically when you use a small little function and turn one data type into another data type. So let's say we have a variable here called example3, and we set it equal to 5, right? You can see here when I print it out the type is an integer, right? You see it's an integer, and it prints out 5. Now, let's say I wanted to turn this 5 into a float for some reason. I just want it to become a float. You can use casting. If you use the float data type name and you put the variable in the parentheses for float, it'll turn this integer, example3, into a float. So I set it equal to another example called example4. And as you see, when I print it out, it comes out as type float, and it prints it out as a float number, so 5.0. So you can just change data types into other data types by putting the name of the data type you want to change it to, right? So another example would be a number variable. We have 55. You can see is of type integer, and yeah, it's 55, right? It's a type integer. And let's say we want to turn that 55 into a string. We just want it to be outputted as a string. We put str, which stands for string, and we put the number variable in as an argument between the parentheses. So when we print out the type for number 2, it comes out as class string, and it comes out as 55. So now 55 is a string. And you can also do it without variables. Like you could change numbers without variables if you want. So you see here, if you put print type of 4, it's integer. You can print it as string of 4, and it turns that 4 into a string. The reason we use variables is because it's gonna hold that value. It's gonna store it into a variable. So like I did this, but if I print 4 again, it's gonna still be an integer because it's not stored in a variable, basically. Now you can also use casting on Boolean variables, but they're a little different, and like they're very unique in how they do it, because you guys know that Booleans are either true or false, right? It's only one or two, one of two values. So we can, oh wait, sorry. Yeah, this is an example, but here, right? We can change a Boolean, we can change like a string to a Boolean, right? So if I have a Boolean, if I have a string called hi, right? And I want to change it to a Boolean, I just put bool, which is bool, and I put the thing I want to change it into in the parentheses. So if I print bool hi, it'll come out as true. And this is unique because if you change a string to a Boolean, then any word you put in it will come out to true, right? So if I put any single word I want into a Boolean, if I want to cast it into a Boolean, it'll always be true. But an empty string will come out to false. So you see here, I put a string hi into a bool cast, so it'll come out as true, and you can see it turns to class Boolean. But if I print out a Boolean, if I turn an empty string, which is literally just this, right? Like nothing in between, just 2 quotation marks, and I try to turn it into a bool, it'll come out as false. Now you can also do the same thing with numbers, right? Like integers and floats. So if you change an integer or a float to a Boolean, then any number you put will come out to true. Like any negative or positive numbers you put will come out to true. As you see here, 10.32, whatever, will come out to true. And you see it's a class Boolean. But if you put a 0 and you try to change a 0 into a Boolean, then that will come out as false always. And finally, with Booleans casting, if you change true or false into a string, then it will come. Oh wait, no, there's more. Sorry. If you change true or false into a string, then it will come out as true or false, like as a written word of true or false, right? So as you can see here, when I put in true for capital T, it's gonna recognize, Python's gonna recognize it as a Boolean variable, a Boolean data type. But if I turn it into a string, it's gonna recognize it as a string data type. And if you, okay, and then also, as you see here, you can try to turn a Boolean into a float, all right? So as you see here, when I put true, it comes out as class Boolean. But if I try to turn it into a float, it's gonna come out as 1.0. Now, so in Python and other languages, Booleans have certain numbers attached to them. So true will always be outputted as 1.0, and false will always be outputted as 0.0. So as you see here, true is 1.0, and false will be 0. Now, casting won't work on some things, right? Like, let's say you have a string you want to turn into an integer, right? So let's say I have a string named David, and I want to turn it into an integer. If you think about it, that doesn't really make a lot of sense because these are words and you're trying to turn it into a number. It doesn't really make a lot of sense. So it won't work on some things. So as you see here, when you run this, it'll give you an error, right? You cannot turn a string into an integer. However, you can turn a string that has a number in it into an integer, because Python will recognize the numbers you put in the string as a number. So it'll turn it into an integer value if you run this code, as you see here, a string into an integer. All right, I know that was a very long-winded explanation on casting and variables. So please, if you have any questions, please ask me right now, because we're gonna go to the next topic. Okay. Okay. So now we're going to go into input functions, which is also a very important concept in Python. So basically, input functions allow a user to input information into a program, right? So this is represented by this little function right here. If I type in input and I put parentheses, Python is going to recognize that as, hey, we want someone to input information into the program. So when we want the user, like because usually when we make programs, someone's going to use it, you know. So when we want the user to enter information, we can tell them what we want them to enter. So we can prompt them by writing the string inside of the integer. So let's say we put a string here, enter your first and last name, and I run this. I can just look at, gives you a little UI here, and you just type in what you want to type in. So my first and last name, David Mena, and now it has that in the program. Now, what's cool about Python is that we can take this information that we inputted and assign it to a variable. So now the variable will hold that information, and then we can do something with that variable, right? So here, let's say we put the same input function that we had before, and we set it equal to a variable called name, right? So name equals to input, enter your first and last name. And then, well, since we have name, we can print it out and actually see the name that we want to print, right? So let's get rid of this for a second, so I can explain that later. And then let's say I just want to print name. We can run it, and first, since this is the first line, Python's going to ask you for your first and last name first. So if I put David Mena, it's going to print out my name, prints out David Mena. So yeah, we could do that, or we can add more to it by printing out a string called hey, and then we add name to it, and then we add an exclamation mark. So if I run this and I put my name in, if I put my name in, it's going to come out with hey, David Mena, right? Hey, David Mena, that's how it is. Now, this statement uses something called concatenation in to combine the elements. Now, concatenation combines strings together at their ends into a new string and then prints them to your output. So it basically just combines only strings, like you only have to use strings for concatenation. Now, this is good when you need to join strings, sometimes constructed elsewhere, together. And you should note that you can only concatenate a string with another string. For example, if I want to combine a variable that holds an integer with a string, it'll just give me an error, right? So let's say I have a string here called David is with a space, and I try to add 21 to it, which is an integer, it'll just give me an error. You see, it can only concatenate string, not integer to string. So you can only use concatenation on strings. However, if you really want to like do this, you can get around it by using casting, right? Like we did before. You can use casting and turn the integer into a string. So if I put string David is, and then I turn 21, the integer 21 into a string, it works out and you can actually print it. Now, concatenation doesn't add spaces, right? Like it doesn't add spaces for you. So let's say if I run it like this, it'll just be like David is 21, right? But so we have to add it ourselves inside the string. So we just put a space, boom, David is 21. Now you can also combine elements using commas. And when you use commas like this, you see how I print a, comma, is, comma, x. Python doesn't care what data type you put in there now. So let's say I set a variable x equal to 25, right? To an integer 25, and I put a variable a equals to David. I can print a, so it'll print David first, and then I put a comma, and then I put my own string in here, I just put is, and then I put another comma, and then I put x, and then boom, David is 25, which I'm actually 21, so let's change that. Boom, David is 21, right? So if you did this with concatenation, then you'd have to turn x into a string. So we'll have the same variables, and we'll print it all with concatenation, and we have to add the spaces and is, you see here how it's different. And we have to turn the x integer into a string, and boom, David is 21. Any questions on input functions or concatenations? It's very important. Like you'll probably use that a lot when you want to make like menus and stuff like that. Okay, so lists. Now lists are very important as well in Python, because sometimes you just have to deal with large amounts of data in Python. So we can use lists to manage it, right? So list lets us store lists of information. We can take various data values and put them inside of a list, which allows us to manage them easier. Now we make a list the same way we make variables. We give it a descriptive name. Sorry. We give it a descriptive name that will describe what's inside of the list, right? So here, we make a list by putting the variable name and we set it equal to what we want to put inside of the list. And to make a list, you have to use open and close square brackets. So you see these, either open and close square brackets. Python will know you're making a list when it sees these square brackets. Now, let's say I make a list called coworkers and I set it equal to 5 of my coworkers. We have Jim, we have Dwight, we have Michael, we have Pam, and we have Kevin, right? So I made a list called coworkers and I filled it with the names of 5 coworkers. Make sure you have to separate them by commas, right? So if you have Jim here, Python knows that that's the first element because you put a comma and then you put the second element and so on. Now, you can put any data type into a list, right? You can put strings, integers, Booleans, whatever you want in a list, and Python won't discriminate. They'll just show everything. So for example, I made a list called whatever, like it's literally just whatever. And I put a string named David, I put an integer to 1, 2, 3, 4, and I put a Boolean called false, and Python will still run it. There's no error. It'll count those as elements within the list. When I say elements, I mean like each one, like every one thing in the list, right? Every item in the list. So this would technically have like 5 elements because there's 5 names. All right, so let's go back to the original list that we made and let's work on that. If we want to print the coworkers and see all the elements of the list, we literally just print the variable, just like in variables, we print the variable name. So if we print coworkers, boom, we have Jim, Dwight, Michael, Pam, and Kevin. It has all of those coworkers. But what if we wanted to get specific elements of the list, right? Like what if we wanted to get Jim, or only Michael, things like that, right? Well, we can access specific elements through a method called indexing in Python, right? So each element in a list has a specific index and they start from 0. Now, pay attention because this is a little weird. Like, so when I say they start from 0, I mean, obviously you see here there are 5 elements, right? So you when you count them, you go 1, 2, 3, 4, 5. But in Python, when you refer to some element's index, you start from 0. So Jim is technically at index position 0. Dwight is at index position 1. Michael is at index position 2. Pam is at 3, and Kevin is at 4, right? So there's 5 elements, but it starts from index 0 and ends at index 4. Therefore, if you want a specific element from the list, you must refer to it by its index. So let's say we want to get only Jim from the list. To do this, we call Jim's index position by typing out the name of the coworkers list and putting the element's index position between 2 square brackets and printing it out. That was kind of a mouthful, but basically you print out the variable name coworkers and you put the open and close square brackets and you put in the element of the index of the element you want to print out. So for example, coworkers square brackets 0 will give us Jim. So it got Jim because Jim is at index position 0. So remember that it always starts from 0 from the index position. Now another example would be, what if we want to get Michael, right? Michael is the 3rd element of the list, but his position is 0, 1, 2. So he is at index position 2. So we call the coworkers variable and we put index position 2 between the square brackets. And when we run that, we'll get Michael from the list. Now that was indexing, but you can also access an element backwards through negative indexing. So yeah, this one's also a little confusing. When we perform negative indexing, we start from -1, not 0, right? So negative indexing goes backwards, right? So you know how when we look at the coworkers list, we start from left to right. So Jim is 0 and so on. When we use negative indexing, we start from the back. So Kevin would be considered -1, and it just goes to the last element of the list. So the negative numbers mean that we start from the elements at the end of the list instead of the beginning. So if you do coworkers -1, it will get you Kevin, right? Because that's the last element of the list. So that's -1. And everyone after that will be the next negative number. So Kevin is -1, Pam is -2, Michael's -3, Dwight is -4, and then Jim is -5. So it just starts out like that. So if we want to get Pam, we know she's negative index number 2, right? -1, -2. So when we print out coworkers -2, it'll give us Pam. Negative indexing is like pretty useful when you have like a large amount of data in your list, and let's say you just want the last element for some reason, or the last few elements, like you can do that. Now I'm gonna print out the coworkers list again just for reference, so we can have it here. Now there's another way of accessing elements in a list, and it's called slicing. Now this one is a little bit confusing as well. Like, make sure you pay attention right now. So when we slice a list, that basically means we're using a colon, right? Just a colon, this colon right here. When Python sees this, it knows that we're slicing through the list. Now, the number that we put on the left of the colon is the index of the element we want to access, right? So if we put 1 on the left, that means we want to start with Dwight. We want to start with number 1, right? And if we, yeah, and then the number on the right of the index is the index of the element after the element we want to access. Now that was a little confusing, but I think it's better just to show, right? So when slicing, Python will grab all the elements up to, but not including the index after the colon. So if you start at 1, it's gonna grab Dwight, it's gonna grab the index 1 and grab everything up to, but not including index number 4. So we know Dwight is index number 1 and Kevin is index number 4. So if it's not including 4, which is Kevin, it's only gonna grab Dwight, Michael, and Pam, right? Let me say this again. It starts at index 1 because it's before the colon. And it grabs everything up to, but not including index 4, which is Kevin. So we just get back Dwight, Michael, and Pam, as you see here. Dwight, Michael, and Pam. So sorry. Yeah, so as you can see, just grab those. So if you put like a 3, if you put a 3 after the colon, right? If it was 1 to 3, it'll grab all the way up to index 2, right? If you put a 3 here, it'll grab all the way up to index 2 because it's not including this. So it'll only grab 1 and 2. If you put like 6, which 0, 1, 2, 3, 4, 6 doesn't exist, right? But it'll grab everything, right? It'll recognize it as, okay, 6 isn't in it, but so we'll grab everything in the list. So yeah, that's like, just make sure you know that it's up to, but not including the index after the colon. Now, you can also leave the number blank before or after the colon, right? If I just want to do coworkers, open and close square brackets, and I just put a colon, it's going to grab every element from the list because Python is recognizing it as, okay, so there's something before or after, so you want to get everything from the list. So as you see here, it gives us all the elements of the list. Yeah, so this could be useful if you want to grab many elements in a list except for a few elements, right? So let's say I want to get like I want to grab the last 2 elements of the coworkers list, Pam and Kevin, right? Let's say I just want to grab Pam and Kevin from the list. We can put Pam's index position of 3, right? So 0, 1, 2, 3, Pam is at index 3. So we put her before the colon. So it's going to start at index 3. And if we put nothing after the colon, it'll return everything after Pam. So it's gonna include Kevin. So now when I print coworkers 3, nothing after, it prints out Pam and Kevin. Another example would be if I wanted to get every element in the list before Pam's element, right? Or yeah, before Pam's element, because we know Pam is at index position 3, right? 0, 1, 2, 3. Pam is at index position 3. So if we want to get everything before her and not including her, we'll put nothing before the colon, as you see here, and then we'll put her position after the colon. So it'll just get the first 3 elements, Jim, Dwight, and Michael. As you see, it brings back that. So yeah, just remember that is very important in slicing. Slicing is up to but not including the element after the colon. Slicing is great because like it lets you grab a bunch of data like at the same time. So if I had like 100 elements in a list, I can be like, oh, what if I want 99 elements? I just start like I put nothing before the colon and then I put 100 at the end. It'll bring me 99. Now we can also modify elements in a list if we wanted to. All we'll have to do is access the element we want to change and set it equal to whatever you want to change it to, right? So this works because lists are considered mutable, which means we can change them. Some things in Python are considered immutable, which means we can't change them, but lists are mutable. So let's say we wanted to replace Dwight for some reason, right? Like let's say we want to get rid of Dwight. No, like we'll have to call Dwight's index position, right? So we know Dwight is at index position 1, right? You see here is Jim, Dwight, Michael, Pam, and Kevin. Dwight is at index position 1. So we call his position and we set that position equal to whatever we want to name, whatever we want to put in that position. So let's say we replace Dwight with Oscar. We set it equal to Oscar. And now when we print coworkers, Dwight isn't in the list anymore. It's just Jim, Oscar, Michael, Pam, and Kevin. That's it. Okay, so any questions on lists and accessing their elements? Okay. List functions. So there are functions already built into Python that let us do certain things to our list. So we'll go over some common list functions within Python. These functions basically let us like manipulate our list to do different things, right? So let's start with let's bring back some let's bring back the coworkers list, right? Let's reset it. It's Jim, Dwight, Michael, Pam, and Kevin. And let's make a new list of numbers, right? Just random numbers. It's nothing crazy. Numbers equal to 10, 3, 100, 46, 58, and 23. All right, so we have these two lists. There's a function in Python called the dot extend function. So when we use these list functions, they start with a dot, a period, right? You always have to put a dot, and they usually start with like the name of the function, and then they usually have 2 parentheses, right? So this is considered the dot extend function. And something about Python is whenever some functions have parameters, they're called like arguments, and you put arguments within the parentheses. I'll show you some examples so you'll get the hang of this soon, trust me. So basically, let's add the numbers list. We want to extend, since the list is extended, we want to add all of these numbers to the end of the coworkers list. So if I put coworkers dot extend, usually the dot functions would come right after the variable, right? So if I did coworkers dot extend, and I want to extend the coworkers list with the numbers list, that means the numbers list will be the argument. So I'll put the numbers list between the parentheses. So it'll be coworkers dot extend numbers. So when I print it, now you see that we have the original coworkers list, Jim through Kevin, but we also have all the elements in the numbers list. And now it's just, now every time we print coworkers, it's going to be that. Yeah, this we did it. This is weird. Sorry. Do that again. Yeah. Okay. Now another function in Python is called the .append function, which lets you add an individual element to the end of the list. So if we want to just put one element at the end of the list, so let's run the old the original coworkers list to get rid of the numbers from the last extend function. So we'll just make it a new Jim to Kevin again. If let's say we wanted to add a new coworker, his name is Andy, right? Let's say we want to add Andy to the end of the list. All we have to do is type coworkers.append, and then we put Andy as an argument. So if we put coworkers.append Andy, and we print out coworkers, now we see that Andy is at the end of the list, right? So we have Jim, Dwight, Michael, Pam, Kevin, and now Andy. So now the element has, the list has 6 elements. It has 1, 2, 3, 4, 5, 6 elements instead of the original 5 that it had before. So note that Andy is now at index position 5, right? So we have Jim 0, 1, 2, 3, 4, and now Andy is at 5. And for negative index positioning, we know that Kevin used to be at negative index 1. Yeah, negative index position -1, right? Because it starts from the end of the list. But now in this new list with Andy being appended, Kevin is at index position -2 and Andy is at -1 because he's the last element of the list. So make sure you're aware of that when you think of negative indexing. Another function is called the dot insert function. So the insert function takes two arguments. It takes an index and an element, and then it replaces the element at the index position with the element of your choice. So it doesn't replace the element at the original index. It just moves that element to a new index position. That was a mouthful, so it's probably easier if I just show you how it works. Let's say we wanted to add a new coworker named Kelly, right? But we want to put her for some reason in position 3. So we know that 0, 1, 2, 3. We know Pam is at index position 3, right? So basically, we just type in coworkers.insert, and this function takes two arguments. Like I said before, it takes the index position and the element. So you put in the index position you want to put the element in. So we put index position 3 here, and then we put Kelly here. So if we print out the coworkers list, you see that it's going to be Jim, Dwight, Michael. Kelly now is at index position 3, and Pam gets moved to index position 4, and then Kevin and Andy. So 0, 1, 2, 3. Kelly's at 3, Pam's at 4. It just moves Pam to the right. Now another function is called the dot remove. So the dot remove function basically lets you remove the element of your choice, and the element you want to remove is the argument. So let's say I want to get rid of Kevin. He did something weird, bad. I don't know. He dropped chili on the floor or something, and he's like gonna get fired. We call the name of the list and we do dot remove, and we put in Kevin in the parentheses as an argument. And then when we print it out, we see that now Kevin isn't in the list anymore. So this is the list we had before: Jim, Dwight, Michael, Kelly, Pam, Kevin, Andy. Now it's Jim, Dwight, Michael, Kelly, Pam, and Andy. Now it's only 6 elements. 0, 1, 2, 3, 1, 2, 3, 4, 5, 6. And yeah, so now Andy's position is, his index position is moved, right? So 0, 1, 2, 3, 4, 5. So now Andy's index position 5 instead of 6. Yeah, so another function that lets us remove elements is called the pop function, right? If I do dot pop with the name of the list, it's going to remove the last element in that list. But dot pop is kind of unique because it can take no arguments. You see here, like I have nothing in between. And if it takes no arguments, it just gets rid of the last element, right? So, you know, originally we had Jim, Dwight, Michael, Kelly, Pam, and Andy. If we do dot pop, you see it got rid of Andy. So now it's just Jim all the way to Pam. But dot pop can also take an argument, right? So it can take an index position argument and it'll remove the element at that index position. So let's say you put any index in here and it'll get rid of the element at that index. So let's say I wanted to get rid of Jim. If I do coworkers.pop 0 and I print it out, now you see Jim isn't part of that list anymore. It's just Dwight, Michael, Kelly, and Pam. Now let's bring back like the original coworkers list, right? Let's bring back this original coworkers list just so we can have our elements back. There's a dot index function which tells you the index of the element you're trying to find. It's pretty simple. You just put the element you're trying to find as argument. So let's say I want to find out what index position Dwight is in. I just put coworkers.index. I put in Dwight, and look, he's at index 1. And yeah, 0, 1, we know he's at 1. Now another function is called the dot copy, right? The dot copy function. It'll basically copy a list that you choose to put before the dot, right? So let's make a variable called coworkers2, right? This is just another list of coworkers. And let's say I want every element from coworkers1 in this new variable coworkers2. I just set it equal to coworkers.copy. And now this copy function basically copies the entire coworkers list and sets it equal to coworkers2. So when we print it out, we have Jim, Dwight, Michael, Pam, and Kevin. So now coworkers2 is the same as coworkers1. Yeah, so let's bring back the number list that we made before the rest of these functions. to show you how, the final ones of these functions, right? So there's a function called .sort, which basically it'll sort a list in ascending or alphabetical order. For examples, for example, if I print out coworkers, you see it's Jim, Dwight, Michael, Pam, and Kevin. If I put .sort, it'll just put it in alphabetical order. So now Dwight is first, Pam is last. You see this? And if we put another example of this would be numbers, right? If I put numbers, it'll start off as 10, 3, 100, all random numbers. But if I put .sort, it starts from the small number and it goes all the way to the largest number. Now reverse. .reverse is another function that does exactly what you think it does. It just reverses the order of the list. So let's say I have Dwight, Jim, Kevin, Michael, and Pam. If I put .reverse, it'll put every element that was last first. So it'll start from Pam and end at Dwight. And the same thing works with the numbers. It starts at 3, ends at 100, and when you put .reverse, it starts at 100 and ends at 3. And the last function we'll go through is .clear. So .clear removes everything from the list. If you put .clear, your list is just going to be empty. So you see here, I have my coworkers list of Pam to Dwight. And if I put .clear and I print it out again, it is now an empty list. And the same goes with the numbers. If I put .clear, the list is now empty. Now, those are some basic list functions that basically like help you see how we can manipulate lists in Python. Now that's basically the end of the basic Python, like the basics of Python. But I wanna teach you guys something called NumPy, like the very basics of something called NumPy in Python, right? Now, since we have extra time, I'll just go over it for you. We'll quickly go over NumPy in Python, which is like a Python library used for working with arrays. Now, an array is arrays are like lists, right? So they contain various elements that can be of the same data type, but they let us store and organize data, and they're useful when we want to work on many values of the same data type. Now they differ from lists because arrays are faster and they use less memory when compared to Python lists. Now I'm gonna introduce you to like imports and stuff into Python, which basically to make arrays, right? To make these arrays that I said are like faster and use less memory than lists, we have to import a Python library, which basically lets us access arrays. So to do this, we import NumPy as NP. So you just type that in. If we import NumPy, it's basically bringing in the library, and as NP is called an alias, so we're just naming it NP, basically. So doing as NP basically shortens the imported name to make the alias NP, and it basically gives us better readability for Python. It's a widely adopted convention that you should follow so that like anyone working with your code can understand it. Because if we didn't do, we could technically just do import NumPy, but we do as NP so that we could like every time we make an array, we just put NP. We don't have to type in NumPy. Now NumPy is important because it's designed for efficiency on large arrays of data. So NumPy only provides like a computational foundation for like numeric data processing, but it doesn't like provide any like modeling or scientific functionality. Pandas, which we'll do in the next workshop, is the basis for like most kinds of statistics and modeling, but that'll be in the next class. So let's go over NumPy. It's not a lot left. It's a few lines of code, and then we'll be done with the workshop. So making arrays is very simple in NumPy. All we have to do is type in NP, which is the alias we have here, and you just .array. So if you put NP.array and you put it in parentheses, because it's a function, it's basically like a function. You see how every time we made a function, we put a parentheses and it kept in an argument. When we call an array, we do NP.array, and then we make arrays the same way we make a list as well. We put open and close square brackets, right? So let's say I want to make an array of 1, 2, 3, and 4. Then NumPy allows us to make this array, and it just has the values 1, 2, 3, and 4. Now we can set arrays to variables, right? Just like lists, right? So if we do np.array of 1, 2, 3, and 4, we can set it equal to A. So when I print out the data type that A is, we can see that it's a NumPy array. And then when we print it out, you see it's 1, 2, 3, and 4. Now, just like in lists, we can use indexing and slicing to get the elements from arrays. So it's literally like just like a list. So if we want to get we want to get the element number 1, right? It's at index position 0. So we'll put print a of 0 because a is the name of the array, and it'll give us 1. We can print a of -1, so it'll give us the last, because it's negative indexing, it'll get us the last element, and we get 4 here. And then a way you can also do this, which is like a way of printing each one, like we talked about before with the commas. So if I want to do a of 0, a of 1, a of 2, and a of 3, then it'll give us the entire array, 1, 2, 3, and 4. But we can also use slicing just like in the list, right? So if I want to print a of 1, 3, it'll give me the first element, the element at index position 1, and it'll give me all the elements up to but not including index position 3. So it'll give me 2 and 3. We can also change the elements in the array, right? So if we want to change the element at index 1, just like in a list, we call the element at index 1 and we set it equal to whatever we want to change it to. So if I set a of 1 to 8 and you print it, the new array is 1, 8, 3, and 4. Now we also have 2-dimensional arrays. Now this is a little different from obviously from 1-dimensional arrays, because 1-dimensional arrays refers to like a single, basically like a single line, right? It's just one array. You see it's 1, 2, 3, and 4. To make 2-dimensional arrays, you don't have to stack it like this. Like you can like technically like just put it together, but it just makes it easier to visualize, right? So if we put np.array and we put the first array 1, 2, and 3, we put a comma, and then we put the second array 4, 5, and 6. It'll print us and we print it out. You see that it's a 2D array. It's the top array right here and the bottom array right here. So 1, 2, 3, 4, 5, 6. That's a 2-dimensional array. Now there are also like some functions in NumPy that let us like see arrays. So if there's a dot shape function that basically shows you the number of rows and columns in an array respectively. So if I put b.shape, we can see that it has 2 rows and 3 columns. So if we come back, we can see this, right? The first row is 1, 2, 3, and the second row is 4, 5, 6. And then there's 3 columns. 1 and 4 is 1, 2 and 5 is 2, and 3 and 6 is the third column. All right. Now this is important to know that when you do dot shape, you do not add parentheses. When you try to add parentheses, it'll like come out as an error, right? So use it to valid parentheses. Now we can also just do multi-dimensional arrays, just like we did a 1-dimensional array and a 2-dimensional array. We could do like a 3-dimensional array here. All right, so we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our 3-dimensional array. I put some comments here to show you exactly like how to sift through it. So if you do multi-dimensional arrays, then like slicing through it and calling the elements are going to be a little different, right? So pay attention. This might be a little weird. So let's say when we go through like arrays and like all these multi-dimensional things, we always start with rows and then it'll go to columns, right? So if I want to print out, if I print out C, which is the name of this array, and I put index position 1, it's going to print out the row at index position 1. So technically, when Python reads this, it reads 1, 2, 3 at index position 1. It prints 4, 5, 6 at index position. Sorry, I'm sorry. It counts the first row 1, 2, 3 as index position 0. It counts the second row 4, 5, 6 as index position 1, and it counts the third row 7, 8, 9 as index position 2. So if I call index position 1, it'll give us the row at index position 1, which is 4, 5, and 6. You see here 0, 1, 2. But let's say I wanted to get like an individual element from here, right? Let's say I wanted to get like 4. I don't want to get this entire row. I want to get 4. Well, we can do this by printing both of the elements, right? So as you see here, I print C, index position 1, and index position 0. So when Python sees this, it's like, okay, so you want the first row and you want the element at you want the row at index position 1 and you want the element at index position 0. So to see this, we'll do this right here, right? Index position 1 is this row, 4, 5, and 6. And index position 0 is this column right here of vertically, right? So Python will go to index position 1, and then it'll see index position 0 with the columns, and it intersects right here at element number 4, right? So then it comes out as 4. And you're gonna do the same thing with a comma and 1 square brackets. It's basically the same thing. Okay, so slicing is just like how it is in lists, right? Let's say we want to get the first 2 rows, because remember, when we use 1 square bracket, it's only going to refer to the rows. So if we want the first 2 rows, we just do 0, 2, because it's up to but not including 2. So it'll give us the rows at index position 0 and index position 1. So when we do that, we see here we have 1, 2, 3, and 4, 5, 6, the first 2 rows of the array. And we can also use slicing to slice through both dimensions. You can slice through the rows and the columns, right? So we use 1 square bracket, and we can use 2 colons, but we have to separate them by commas. So the first colon represents the rows, and the second colon represents the columns, right? So as you can see here, when we call the first colon, right, it has nothing before and after, which means we want all of the rows, since this represents rows. So we want every single row. It's going to give us all 3 of these rows. And then the second thing we slice through is the columns. So we want every column up to but not including 2, which means index position 2, which means we're only going to get the columns at index position 0 and 1. So it'll give us every single row and only the columns at 0 and 1. So it should be 1, 2, 4, 5, and 7, 8. And when we run it, we see it's 1, 2, 4, 5, 7, 8. I know it's like a little hard to get your head like wrapped around it. It's just, a matter of practice, I suppose, with slicing and indexing. But we can go through like statistics of an array with Numpy, right? So let's say I bring back the original array and I just put a equals np.array and I go 1 through 4, right? If I print a, you see it prints out the array. And if I do a function called .sum, I can print out a.sum and it'll sum up every element in the array. So you see here it adds up to 10. If I put a function called .mean, it'll give us the mean, the average of the numbers in the array, which is 2.5. And STD stands for standard deviation, so it'll give us the standard deviation of the array, which is this big old number here that we don't have to worry about. But that's just like to go through statistics and stuff. Does anyone have any questions about the slicing and multidimensional arrays and stuff like that, like statistics? Okay, so we can also do like statistics for multidimensional arrays. So you see here, we make another 3D array, 1, 2, 3, 4, 5, 6, 7, 8, 9. We set it equal to B, right? So B is this 3-dimensional array. We print it out or print it like that. If we use the sum function, it adds up every element in here and gives us 45. Now, there's something very unique about the sum function and like arrays. If we want to like just sum up the rows or the columns, we have to use access equals as an argument, a parameter in the sum function. So let's say we want to sum up only the columns, right? We want to sum up all of the columns. Well, we'll do b.sum, and as an argument, we'll put access equals 0. So when it comes out, it's going to print this right here, this array right here, 12, 15, and 18, because it adds 7 plus 4 plus 1, which is 12, and 8 plus 5 plus 2, which is 15, and 9 plus 6 plus 3, which is 18. And then we're going to do the same thing with access equals 1, and it'll print out the sum of all the rows. So 3 plus 2 plus 1 is 6, and so on. Yeah, so that brings us to the end of the Python workshop. Thank you for joining us. That was all of the basic Python that you should know. And then NumPy is a little more advanced. So like if you couldn't keep up, we can go over it again next workshop. But I just wanted to do it now so you guys can get a sense of arrays and how they're similar to lists. And I'm going over NumPy because NumPy is related to pandas a lot, right? Like there are many more things you can do with NumPy, but I wanted to give you a sense of what NumPy does because pandas, which we'll be using next workshop, is a package that is like built on top of NumPy. It's kind of related to each other. So yeah, if you have any questions, you can feel free to write them in the chat or unmute. This is everything. Yeah, sorry, like I know it was a little quiet. I might have rushed some things, but definitely if you have questions, you can text me in the AIS Discord as well. But all the materials, like the whole material we used today, the whole the file is on my GitHub, which I put, it's in the chat, but it's also in the Discord in the announcements page. So if you want to just go through it, you can like look at everything I did and all the comments that I put to explain it. And also we've been recording this session, so that's going to be uploaded to Discord later today. But yeah, if there's no questions, I mean, you guys can feel free to log off, but definitely ask me if you have any questions. The Discord link, let me see where that is. Give me a second. Sorry, hold on. Okay, oh yeah, well, Chris, yeah, thanks, Chris. I'll put in the chat right now. That is the Discord link to join our AIS Discord. Yeah, feel free to join. You guys can ask questions and know about other workshops and other events from other committees like data science and cybersecurity, software development, things like that. But yeah, thank you for joining me, guys. You guys can go whenever you want, I guess. So yeah, next Tuesday is gonna be our next event. Well, we're gonna use pandas and matplotlib to go through a data set of the Bachelorette, like a show, and we'll just like manipulate it and have fun with that next time. So thank you, everyone.
Thanks, guys.